All right, so for example number 2, just know that the last video I had to cut off due to time. But for example number 2, we're going to look at the approach the exact same way. So first thing we want to identify again is our our HK, or what our horizontal and vertical asymptotes are. So again, since we have a horizontal asymptote at y is equal to k, and we have a vertical asymptote at x is equal to h. So our horizontal asymptote, right, is at y is equal to -1, and our vertical asymptote is at x is equal to -5. Because again, that +5 means that h is actually negative. So I'm going to go ahead and graph those. Again, my point where they intersect is going to be at -1, -5. So sorry, -5, -1. So -5, -1, which would be right here. And so my graph would look, or my asymptotes would look something like this. And before we actually start plotting, let's go ahead and start filling in the table values that we actually already know. So before we go into domain range, so let's talk about the parts that we already can guarantee. We know that there's no maximum and minimum value. We know that, yes, it's 1 to 1. We know it has non-linear slope. We know we're not going to concern ourselves with the axis of symmetry. And then we know our vertex is at HK, so in this case would be -5, -1. It's not really vertex, so to speak, but where our points intersect. So now we want to kind of figure out we actually already know what the horizontal and vertical asymptote is. We know that the horizontal asymptote was at y is equal to -1. And we know the vertical asymptote is at x is equal to -5. And so that's everything that we know so far. So now we need to figure out the domain range, increasing, decreasing, and then what my intercepts are. Okay. So in order to do that, first thing we want to do is we want to graph these guys, right? We want to graph this. So again, since we have that -2 there, okay, so a couple things are really happening, right? This one right here, right, this negative, because that's negative, that means that we have a reflection across x-axis. So if we look at number 1, we can see essentially that our graph was in quadrant 1 and quadrant 3. This time our graph is going to be in so it's going to flip. So our graph is actually going to be, again, across the x-axis. So our graph is actually going to flip here and flip here. Okay, so now instead of being in 1 and 3, we're going to be in 2 and 4. Okay, so that's where our graph is going to be, and we're going to go about it kind of the exact same way that we did before, right? Again, you can do a table of values if you'd like, right? But again, we're kind of graphing these using transformations. So what we're going to do is I'm going to go essentially left. So instead of going left one down 1, instead I'm going to go left 1 up 1. Now we have to also take into account this 2, this a here. Because that is modifying our y values, essentially it's going to double up how far we go up every single time. So now instead of going left 1 up 1, we're going to go left 1 up 2. Okay. So, and then instead of going left half up 2, we're actually going to go left half up 4. And then instead of going left 2 up a half, we're now going to go left 2 up 1. Okay, and we're going to do the same thing on the right hand side. I'm going to go right 1 down 2 instead of down 1, right 2 down 1 instead of right 2 down a half, and right a half down 4 instead of right a half down 2. And then I'm just going to kind of complete my curve. Again, getting really, really close to those asymptotes, but never quite touching. And this is what my graph is going to look like. So again, in this case, you can see we have both an x and y intercept. And so we want to, first thing we want to do is we want to talk about domain and range. Our domain, right, is going to be from -infinity to h, and h in this case is -5. in union with -5 to positive infinity. And again, we can see that as we move left to right, -5 is the only value that's not included in my domain. All right, and then the same thing is going to be for range. It's going to be from -infinity up to -1 in union with -1 to positive infinity, because we're going to get the only value that can't be in y, essentially, our subdomain is -1. Increasing, decreasing. Now before, when it was regular, we noticed that it was always decreasing. Now that we have that flip across the x-axis, again, you can see if you move from left to right on this graph, our slopes are actually always positive. So instead of decreasing always, we're going to be always increasing, and we're always going to be increasing along the domain. Okay? So again, we're always going to be increasing or decreasing on the domain, okay, for these functions. Now, last thing that we want to do is our x and y intercepts, and again, we're going to solve this just like we did before. Okay, so for our x-intercept, let's do our y-intercept first. All right, we're going to set x is equal to 0. So we have y is equal to -2 over 0 plus 5 minus 1, and which is equal to -2 over 5 minus 1. We got to switch that -1 to denominators. So we have y equals -2 over 5 minus 5 over 5, which is going to give me -7 over 5. Okay, so my y equals -7 over 5 is going to be my my y-intercept, and you can kind of see that that's about right there. So we're pretty close on our graph anyway. Okay, so our y-intercept is going to be at y is equal to -7 over 5. Right? I'm sorry, I did that backwards. Is going to be at 0, -7 over 5. Actually, I cannot write right now. All right, or another way of saying that is y is equal to -7 over 5. Now for our x-intercept, right, we're going to do the same thing. For our x-intercept, we're going to set y is equal to 0. So we have 0 is equal to -2 over x plus 5 minus 1. I'm going to add 1 over. I get 1 is equal to -2 over x plus 5. All right, I'm going to put that over 1, and we're going to do our cross product property, which tells us then that we have x plus 5 has got to equal -2. Subtract 5, and get x is equal to -7. Okay, so, and again, we kind of already knew that in the way that we plotted this, right? That was going to be our y-intercept, or our x-intercept. So our actual x-intercept now is at -7, 0, or x is equal to -7. Okay, and that's kind of how we can graph and identify the defining characteristics of these guys. Please go ahead and slow down these videos and pause it when you need to, in case you are struggling or in case you are not really sure where I'm getting these values from. You can always feel free to kind of Google search these if you need to, and you can use Desmos to kind of aid you as far as your actual graphing. Anyway, have a great day, you guys. Good luck with the assignments today, or with the assignment today. Thanks.